My name is Rob Allen, and in this session, we're going to be talking about HTTP APIs within the context of Slim Framework. So let's get to it. What I want to do today is talk about HTTP APIs or RESTful APIs. So let's start by thinking about what an HTTP API is and then take it from there. So the first sort of property of a RESTful API is that they operate on a representation of the state of a resource through HTTP verbs. It's quite a lot of text to say that this came from a academic paper, doesn't it? Essentially, we have the concept of representations or payloads going across the wire, and we care about the HTTP verbs to tell the system what to do with this data, which makes it HTTP native. So we've got the verbs for operations. We have headers to control content formats, to control caching, things like that. That's built into HTTP, and hence we get it as part of our API. Status codes have meaning in an HTTP API, and we have a layered system. So we have proxies between us and the client, as you would expect on a HTTP system. We have a uniform interface. We have predictable endpoints. We have predictable operations on those endpoints because it is just standard HTTP. And for a RESTful API in particular, we will have hypermedia controls, which is just a way of saying we will have links to inform our client about state transitions, i.e. what to do next. This is great for discoverability. So if we look at a typical HTTP request, this is a put request, so we know what we're going to be doing with this. And the top line is called the request line, where the method is first. This matters a lot, as I said, because that depends on how we're going to operate on this data. So we've got a put request, so we know that we've got the full representation of the resource that we're going to be accepting to replace the copy we have. And then we have the URL users / an ID, which tells us which particular user we need to update. Then we have the data itself, which is the payload, just a name and an email in this case. And we have the content type header because we need to have or need to know how to decode, how to understand this payload. And finally, this client has told us that they can accept application JSON in response, which is quite helpful for future proofing in that we can control the data we send back to them based on the formats that they can accept. We will then send back a response. First line is going to be the status line, where we've got the version of HTTP, which is 1.1 in this example, and then we've got the status code 201 created, which means that this was a successful operation. Again, we have the body that we're returning back to the client. So we are returning back what they sent us, a name and email, and we're also sending back the links section, which is the hypermedia, to tell the user some further information. In this particular case, we are just saying this is the canonical URL to this particular representation, this particular resource. And finally, we have the E tag, which is an HTTP content header, which allows us to do things like detect edit clashes. So the client can use the if match header to detect a mid-air edit collision, because we'll send back a 412 if we have changed our representation before the client, between when the client retrieved their data and when they're sending back the change. The client can also use if none match in order to handle unchanged resources, which is quite cool. So let's look at Slim itself. Slim is a micro framework. It's just the C in MVC. It's very much a PSR type framework. So we've got auto-loading, we've got request response objects based off PSR 7, we have middleware and request handlers from PSR 15, we support DI containers with PSR 11, login of PSR 3, etc. The rest of it, you bring your own components. As I said, microframework. Our starter will provide you the router, the dispatcher, the dependency injection container, and the logger. You'll need to bring your data mapper, your ORM, your view components, your queuing system, everything else you need, you provide. And that's where, of course, Composer really comes into its own. Talk about Composer. Create your project using Composer Create Project and give it a name, and then you can simply start a web server. Here I'm using the PHP built-in one. Traditionally, nowadays, we'd probably use a Docker container or something like that. And we have a working minimal slim application. Talk about APIs, so we're going to use curl. I take it that if you're going to be doing lots of API work, you will have an HTTP client of some form. Me personally, I'm a fan of curl on the command line, but equally something like Postman or its equivalents like Insomnia are really, really good for dealing with HTTP and inspecting what's going on. So here we're going to send a simple curl request and we're going to get back a simple response. And as you can see, it's just a simple hello world. Let's build an API. Rather than doing a CRUD API, a simple put to the user, get back from the user, let's do something slightly different and play a game. The rock, paper, scissors game, in fact. It's not a particularly complicated game, so it maps to an API relatively easily. In fact, we only have 4 operations. We need to create the new game, we need to make the first player's move, we need to make the second player's move, and we need to get the results. That's pretty much it. It's nice and simple. So how would that work out as an API? So let's work that through. Need to create a game. So we're going to post to /games with player names. So simple curl command again. The -d on the third line posts some data. In this case, it's JSON format. And we're going to send it to the /games endpoint. And we're going to get back a response, a 201 created, because we've successfully created a new game. And we're going to get back a link to tell us what the next thing to do is, which is make the player's move. So let's make the first move. Again, it's a post request. This time we're going to post to the moves collection for this particular game with player one's move. Again, simple curl request, just saying the player name and which particular move this particular client, this particular player wishes to do. So player Rob is going to use the rock. Successful. So we get 200 OK, and again we get the hypermedia to tell us what's next, and what's next is player two's move. Again we post back to the same endpoint, but this time we are going to send back a second player, which is John, and John also happens to have picked rock. So we've had 2 players both choosing rock, which has resulted in a draw. Obviously, as both players have played their moves, the API can determine the result of the game immediately and sends it back, which is why we get the result, which is a draw. And then the hypermedia is providing us, well, what's the next option you can do? Logically, we can start a new game by posting to the /games and play the game again. That's it. That's a simple API. It's not a CRUD API, but it's an API all the same. It's fairly RESTful. It does achieve its intention. How do we build that? Let's build the API. Firstly, we need some routes. These are the operations. In Slim, a route is a combination of the method used and the URI to post, get, put, patch, or whatever to. In this particular case, we have 4 routes, which are on 3 different endpoints. We have a get to /games, which will list all the games, post to /games, create the new game, a get to /games / its ID to retrieve information about a particular game, and a post to the moves collection within the game in order to play the moves. That's all we need, so it's a fairly small contained API, not very large. Looking at creating a route, in the Slim Starter, we're going to put them in config routes, and it's a fairly simple request, or a bit of code in PHP. we have an app object, and we call the post command on that to say we want to register a new post endpoint. We can use get, we can use post, we can use put, we can use patch, we can use delete. It's a straight mapping from the method to the HTTP verb. But if we need a particular endpoint to support more than one method, then we can use any, or we can use map and specify a list, should we wish to do that. That makes life a little bit more complicated though, because now that your handler's got a lot more stuff going on inside it, so I would recommend trying to avoid doing that if you possibly can. Routes have a pattern. So this is the URI that we're going to match against. So here we're just doing simply /games, which isn't particularly complicated because it's just a simple list. But we can do a little bit more complicated stuff. We can use braces to create an attribute. So /games/braces ID will enable us to have a placeholder which is each individual game's ID, and we will all match to that particular handler. We can constrain that ID via regex. So this particular example here, /d plus, enables us to say that it's going to be a number only, or we could put it in square brackets to say that it's optional. So it may or may not exist, which is pretty flexible. It's going to have a handler. So the handler is a PSR 15 handler, and usually you can either provide the string name to the class in question, or you can provide a anonymous class directly or anonymous function directly here. My personal preference is to have each handler in its own separate class. The root handler is going to receive a PSR7 server request. It will perform the required operations, and then it will return a PSR7 response. So this is what one looks like. Here's our root handler. List games handler implements the request handler interface. Traditionally, you have a couple of functions involved. The constructor is where you're going to have your dependencies, so that when the dependency injection container instantiates our handler, we have all the required instances of the things we need to perform our operation. And then we have the handle method, which is a requirement of the interface itself. It actually takes a server request interface, which has been aliased to request in this example, and it takes a response interface, which has been aliased to response, mostly to make the code fit on the slide. So let's look at our handle function. Here's list games handler. This is going to handle our input first. We're going to do that by looking in the request and retrieving the query parameters. Maybe we want to be able to filter the list of games, maybe by which player won or something like that, for instance, or just the games for one particular player, or all the games that were a draw. Things like that we would do via query parameters on our collection endpoint, and get query parameters will enable us to do that. Generally makes your life easier if you do some logging. So we've got a logger hanging around, and we're going to create a log entry so that we know what's going on. Obviously, there isn't just query parameters. We have headers as well, which we can retrieve using getHeader, which will return an array, or getHeaderLine, which will return a string. GetHeader is particularly useful for those headers that are allowed to have multiple data inside them. For body data, we can use getBody, which will return the string representation of the body, completely its raw information. Or we can use getPassedBody, which Slim will have interpreted the body based upon the content type header and structured it into an array for us. So if it's JSON, we will have turned it into an array. If it's XML, again, we will have converted that XML to an array, just to make life easier. And obviously, Slim is flexible enough that we can register our own parsers. So if, for instance, we wanted to accept CSV format, we could parse a CSV again into an array or something like that to make it easier to use. That's where the flexibility of parsing of the body really comes into its own. And we're going to do the operation, the actual work that this particular endpoint is going to do. In list games, all we need to do is hit our games repository, and we're going to call fetch, which will return all the games into a collection of some form or another. Obviously, you're probably going to have more operations depending upon the complexity of your API. These will probably be handled in other classes, which were injected into this one in order to make your application easier to maintain and nicely decoupled. And finally, we're going to send back a response. So now the response is a JSON object, and it's really, really tempting to take the data that you've just received from the database and send it straight down the wire. Try not to do that. That's not particularly helpful because you have now coupled your response to your data and you probably need to evolve them at different rates. So even though it's an API, we still have a view layer. The way the view layer in this particular example has been implemented is via the concept of a transformer, which is from the PHP League, which will take our data and transform it into a JSON response, which we can then send back down the line. So this is important to decouple your representation. So we've got our database, we have our entity, we have our application logic, and taking all that, we should create a resource, which is the thing that we want to send back to the client. This will have properties, it will have links, it might have forms, it might have queries, depending upon how you are building the data payloads that you care about. And then you render that to JSON, which is your representation that is rendered into the response object itself. The actual format you use for your representation, it's up to you, but I recommend thinking a little bit about it. So there are a number of choices: collection JSON, HAL, JSON API, JSON LD, or Siren, and others. There's quite a lot of them, and I highly recommend that you think about which one you like and then use that one. Me personally, I tend to use HAL. So we've talked a little bit about APIs and we've talked a little bit about Slim Framework, and we've gone through how to do the list games handler within the API of rock, paper, scissors. So the next one that we want to implement, the next operation, will be create game. How do you implement and start off a game? So what I thought I'd do is do that via code. So let's swap over to my desktop and we can build this next operation. As you can see, what I have here is a terminal window, and I've got the built-in PHP web server running. So we've got our API running on port 8888. I've got another tab here where I can execute curl commands so that we can actually watch and operate our API. So let's list the games. So curl -i http localhost :8888/games. And you can see we have an API, we've returned some data, and precisely no games exist in the API at the moment. So the next thing that we need to do is actually implement the create game post command. So to do that, we're going to need the create game handler, which is here. And as before, you can see we've got the constructor with a logger interface and a game repository, and we've got the handle method, which takes the request and needs to return response. There are a few squiggles because PHP Storm is very well aware that I'm not using my dependencies. There's no use of the logger, there's no use of the game repository, and it's also very well aware that the handle method needs to return a response and currently doesn't. So we could start by just sort of fleshing this out. First of all, we're going to have to handle the input. Then we're going to have to do our operation, and then we're going to have to do our response and do something like that. So let's start by handling our input. This is a post request, so we're going to receive player 1 and player 2 as strings. These will come in as pass data, so we can do $data equals it's an array $request get parsed body, and that will retrieve the JSON data converted to an array into our data variable. As we are good citizens and we need to maintain this, we will log this data. So this logger, this needs to be info creating a game. And we'll pass in the data that was sent through so that our logs contain player 1 and player 2's information, and we can help hopefully diagnose any issues that occur. That's all we need to do for handling our input in this particular endpoint. Next up, we need to create a game. So to create a game, we need a game ID. So let's create the game ID first. We have a game ID model for that, which takes a from UUID, which will generate a UUID and put it in our game ID for us. So we've now got a game ID that we can use, and now we can create our game. We'll use a named constructor on the game model called newGame, which takes the game ID and also takes the data that's been posted in, like so, and that will generate our game. So if I drop through to the new game method, you can see it here, and the first thing it does is validate the new game data. So if I jump through to that, you can see that we check that player 1 and player 2 both exist, and if they don't, it's going to throw a validation exception. So our model is doing the validation for us. So if we successfully validate, we then instantiate a game and set up the player 1, player 2 and our game ID and return the object. Back to our game handler, we now have a game. That's all well and good, but it's a bit ephemeral at the moment. So the first thing we'll do now is save it to the database, which will use the game repository. So I can do $this game repository, and I can add my game to the repository, which will save it to the database successfully. That's all for our operation. Not very much going on here. Very, very simple. Instantiate a game, put in the data from the client, and save it to disk or to database. I'm using SQL Lite in this case, so it literally is going to disk. What do we do now? Next, we need to return the response. So let's create a response equals new response. And we need a PSR7 response, like so. We now need to fill in the body. So let's create some JSON for the body. JSON encode. Oops. It's going to be an array of data. We better pass in the ID, where we can use the game ID that we created earlier as a string. We could pass through player 1, $game, get player 1. We could pass in player 2, game, get player 2. And we could also pass back the status, $game, get status. So the client knows the current status of this game, which, because it's just been created, you would expect it to be unplayed, or whatever the variable statuses are. Let's throw an error if we fail to create the JSON, and let's pretty print it because that makes it look nice. So now we have a JSON string. Let's add that to our response. So that goes into the response's body. We write it in our JSON. So now our response has the data and it's in JSON format, so we had better set the content header, which we can do using response with header content type of application JSON, and we need to reassign that back to the response because with header is immutable, and we probably want to set status code with status code to 201 because we've just created a new game. And finally, let's return our response back to the client, which should make PHP that much happier. Right, let's test that. I go here, clear that again, curl -i. We're going to post some data, so we better set a header, the content type header application JSON. We are going to post it to our games endpoint, /games endpoint, and then we need to actually provide the data itself, which is in JSON format. Firstly, we have player 1, which we'll have as Rob, and then we'll have player 2, which we'll have as John. We run that, and it successfully worked. We have 201 created, all fine. ID has been set to that massive long string, player 1, player 2, and we have a status of empty string. That's a little strange. I wonder why the status is a empty object. Probably because it's null. So if I go to status and have a look at it, it's a game status object. So what I probably need to do, go back here and convert it to a string. So JSON encode did not know how to encode an object, so it just put in the two braces. Let's try that again, and there you go, status is created. So we have successfully instantiated the ability to create new games. What's missing? Next thing that is missing is hypermedia. We haven't got a way to tell the user the link where to go next. So let's implement that. To do that, what do we need to do? We need to create a HAL object. So let's go back here. So instead of doing it all like this, we need to create a HAL object with the data. So let's go back to here. So we create a HAL object, new HAL. The HAL object I'm using is from Ben London, which is no carrier /HAL on GitHub, which is a nice, easy to use one. It takes a URI and it takes the data. So the URI is going to be the base URL, which we can get from the request. Get attribute base URL. And we need to add to that games $game ID toString. So the URL will be the base URL /games / that UUID. And then we need to pass in the data that we want as well, which needs to be an array, I believe. Yes, needs to be an array. So this is the response data, like that. So let's get rid of the JSON encode and just do response data here, because we're going to let the HAL component actually worry about encoding the JSON for us. So now we have a HAL object which knows the URL and it knows the response data to be sent back. What we can do now is we can write that data to the body, which we do by $HAL as JSON. And I think we'll pretty print it. It's always nice to have pretty print data. We still need to tell the system what the content type is, but instead of it being application JSON, it is now application HAL plus JSON, and it's still a status code of 201. So let's try that. Where we have that. Okay. Right, so let's run that and see what happens. And there we go, and that has worked as well. So again, you can see we've got our 201 created. We have our content type is now set to application HAL JSON. The HAL component has correctly encoded our data, and it has also included the link section. So this is our hypermedia section where we've got the self link. And now we can add the additional ones like the next move. So let's add that next so that we can tell the client what to do next. To do that, we just do HAL, add a link. It needs to have a name, so let's call it next move. What's the next parameter? The next parameter is the HAL link itself. So that is going to be the same as self because it's a post. And then we need a description, which is an array description of make a player's. Let's use double quotes. Easier to do the possessive that way. Like so. Having done that, we can now go back here, run the command again, and we get a massive error because we made a mistake. Application could run the following error. I should really turn off HTTP errors. Type error. No caret add HAL link. Argument 2 must be of type HAL link a string given. Which is presumably why we have that, so that needs to be a new HAL link, which takes the string. Like so. If we run that again, we've still got an error. Too few arguments to HAL link. That takes an optional or additional attributes, which there aren't any. In our case. There we go, that's better. And now our hypermedia, our link section, has now got two links. Got self and it has next move, which has got the correct URL in it. And we're all done. So that's it. That's the key things I wanted to tell you today. I wanted to show you that you can create an HTTP API very successfully, very easily, if you think about the key parts of your application. And that is really important to get these things right. And pretty much it. We're all done. So that's it. Thank you very much for paying attention. And if you want to actually see the source code for this entire project, I've put the link up now. Goodbye.